Hi, everyone. Thank you again for joining today's installment of the Robin webinar series. My name is Matt Miller with the Robin team, and I'll be your host for today's webinar. Just a couple of housekeeping items before we jump into today's topic. First, you are all on listen-only mode as to alleviate any background noise on today's session. So if you do have a question, please feel free to enter it in the questions module on your GoToWebinar dashboard that you should see on your screen. We will leave some time at the end of the presentation to go through as many of your questions as we can, time permitting. And lastly, today's session is being recorded and you will be sent a link after the presentation, which you can feel free to share. So with those items out of the way, let's get into our presentation. I'd like to introduce our speakers for today. We have Ankur Desai, who is the Director of Product Management at Robin.io. Good morning, Ankur.
Hi, Matt.
And we also have Madhura Gaunakar, who is the Principal Engineer here at Robin.io. Good morning, Madhura.
Good morning.
Great. So Ankur, without further ado, I will hand it off to you to start today's presentation.
Thank you, Matt. Hi, everyone. This is Ankur Desai from Robin. And today we are going to talk about how to simplify storage and data management operations on Kubernetes using Robin Cloudnative storage. Now, one might be wondering, is there a need for a Cloudnative storage stack, right? One can always argue, I already have a SAN system or a NAS system. Why should I look for other solutions when I can connect the SAN to my Kubernetes cluster using a CSI plugin, right? So here we have to keep two things in mind. One is Kubernetes was, initially built for stateless applications, but looking at the benefits and the flexibility of running those applications on Kubernetes, now there is a strong desire to run stateful applications on Kubernetes, right? So it was not built essentially for stateful, but there is a strong desire to do so. And the other challenge is when you are running these stateful applications on Kubernetes, the primary benefit is going to be the flexibility and agility, right? You can spin up containers faster, you can actually collaborate faster, automate a lot of things. So it doesn't make sense if you bring the stateful applications on Kubernetes, but your mode of operation is still, creating IT tickets to get volumes on your SAN, and then creating tickets for backing up those volumes. It takes away a lot from your agility and flexibility, right? So keeping those two things in mind, here are the key requirements why you need a Cloudnative storage stack, right? And there are different layers of depth to these requirements. The first one is data should always be available even if the pods or disks fail. Right, so the Kubernetes with its persistent volumes and CSI actually helps with some of these things, but you also want to make these volumes highly available, right? So that's criteria number one. Without it, there is no further improvement on stateful applications at all. But let's say you take care of that. The next challenge is, the DevOps teams and the developers who actually are the primary users of Kubernetes, they are not necessarily storage experts. Now, how do we bridge the gap? How do we make sure that the developers can actually perform or at least automate most of the operations that were conducted by storage admin, right? So that is another challenge. Another one is predictable application performance, right? So if you are sharing a cluster, which is, in most of the cases, that is the reality. Let's say you have 3 databases running, 3 Postgres databases running on the same cluster. How do you make sure that each gets its own share of IOPS and, the performance is predictable? Number 4 is the day 2 operations, ongoing operations, right? Once you have databases running, now, how do I snapshot? How do I clone the database for test refreshes? How do I create backups? How do I take care of DR? Many of these things were taken care by the storage admins, right? Now you have to have the developers capable of doing these things. And last but not the least is the observability, right? So how do I observe the entire end-to-end dependency of an application? Let's say if a disk fails, how many persistent volumes are affected, right? And how many dependent pods are affected? And based on that, how many applications can go down and which are the users that should be notified, right? So there is a whole list of dependencies and typical blast radius for any failure. And you have to be very well aware of what that is. And this is where Robin Cloudnative Storage comes in, right? So it is a Cloudnative storage stack, which means, this is not external storage system that you connect to Kubernetes. This is a standard Kubernetes operator, which you will install on Kubernetes. And then it creates a SAN-like experience right on top of the Kubernetes cluster, right? So when you deploy a stateful application, you simply say my storage class is Robin, and then Robin takes care of the rest, right? It will create the persistent volumes. It will make sure they are highly available, highly performant. So this makes it really easy for the DevOps teams and developers to actually use Robin, right? Because a standard operator, it takes 2 minutes to install on Kubernetes. Now, this operator, because it's a standard operator, can actually run on any Kubernetes, right? Upstream Kubernetes, OpenShift, Anthos, or any of the cloud managed services flavors. And when you run it on, a non-managed service, right? When you taking care of your Kubernetes cluster yourself, you have multiple options, right? You can do it on-prem, on bare metal servers or virtual machines, or you can do it in AWS or Azure, right? These are the public clouds. Robin supports all of these underlying infrastructure environments. So in a nutshell, Robin now gives you the ability to basically create a SAN-like storage system right on top of Kubernetes cluster and make it available for your stateful applications, right? And we'll look at what are the other benefits in terms of day-to-day operations and application deployments. But before we go there, I just want to actually talk about a few proof points of our success in the market. So Robin is trusted by multiple Fortune 500 companies for running their mission-critical applications. So at Palo Alto Networks, we are running 6 petabytes of big data applications, including Cloudera, on Robin. At USAA, more than 2 petabytes of data running in Elastic Stack and Kafka on about 300 nodes, right? It's a massive deployment, and this is very critical for their day-to-day operations. And at Sabre, more than 400 Oracle databases running on Robin. Right? Now, if you're looking at a few third-party recognitions, Robin has been recognized as the leader and outperformer for Kubernetes storage by GigaOM. Gartner actually has featured us in multiple foundational nodes for Kubernetes as well as cloud-native storage. And IDC recently recognized us as an innovator in the Kubernetes storage space. Right. So these are a few proof points for Robin Cloud-Native Storage, where we have demonstrated strong success over the past few years. Now let's talk about a few things that you would require to successfully run stateful applications on Kubernetes, and let's talk about how Robin delivers that. Right. So on day 0, when you're deploying the application, there are certain requirements, right? The first requirement is, data has to be persisted, and it has to be always available, right? So those 2 things are critical. And sometimes you have strict performance requirements. So in that case, you need placement policies. Like I want data locality. I want compute storage affinity for my Postgres database to make sure its performance is optimal. So all of those things are needed at the time of deployment on day 0. And Robin provides you just that, right? So for storage, it's basically a cloud native storage that I said, like I said, It's a lightweight operator that installs on any Kubernetes. It installs pretty quickly, and it discovers all the local disks and even cloud disk or SAN systems to make sure we create a common pool of those resources to create a storage system for you. In terms of high availability, we actually have strictly consistent replication and auto resync of replicas if a replica falls behind. And we also make sure that there is fast failover between replicas. If a disk goes down and the pod is connected to a volume on that disk, we make sure that the pod quickly connects to the replica without having a split brain scenario. And the third one here that is very important is the advanced placement policies, right? Like I said, sometimes you might want compute and storage locality, or you might want anti-affinity between specific volumes for a given application. You could say, for my MongoDB deployment, the replicas for the same shard should never be located on the same disk. Otherwise, it kind of defeats the purpose of replication. So you could state these policies for Robin, and we will make sure that your deployments adhere to these policies. Now, beyond day one, right? So this is, let's say you have successfully deployed your MongoDB or Postgres database, and you have made sure the performance is optimal. You have also made sure the application is always highly available, right? There are other day two requirements where, on an ongoing basis, you have to make sure of certain things. So one is predictable and stable performance. Here, Robin provides bare metal performance, as well as things like live data rebalancing, right? So if there is an IO hotspot, we'll make sure that we detect that and we inform the developers so that they can actually start rebalancing of the data without taking the application down. We can also cap IOPS to avoid noisy neighbor challenges, right? So for a given application, we can cap IOPS and say, okay, this is the limitation for MongoDB application. It should not use more than that. Capacity management is another key feature where you should be able to add or remove disks to simply increase or decrease the capacity of storage available on your Kubernetes cluster. So this is, once again, it's pretty simple with Robin. As soon as you add a new disk, it will be detected, and you would add it to the Robin storage resource pool. Robin also allows you to grow and shrink volume size, right? So you can start small, and as your data needs grow, you can then grow the volume instead of basically blocking the entire disk for a given volume. Observability is another key feature where you have to map storage allocations from apps to nodes and disks, right? So to get the detailed metrics, to make sure everything is working fine, and in the event of a failure, you have to know what the blast radius is. And the last one, which is, which typically is in today's world is taken care by the storage admins, is the data management capabilities, right? This is where we have to make it super simple for developers and DevOps engineers to use storage. And Robin has single commands for snapshots and rollbacks, and we'll demo some of it today. Madhura will demo how you can actually create a snapshot of a Postgres database on an OpenShift cluster, and you can how you can back it up to a cloud, and then if my original cluster goes down, I can recreate the same application in the same exact state on a different cloud or on a different cluster, right? So these things are typically not in today's world not done by developers, but Robin can easily make it a process that is a single command, or even a part of the CI/CD pipeline. Now, how do we make it simple, right? I think I have mentioned multiple times that we have to make storage simple. We have to make data management simple for stateful applications, so that developers don't have to rely on IT tickets for some of these tasks, right? So one thing we do is we basically make Robin storage application aware. So here, when you deploy, let's say, a Postgres database, you're not deploying only the persistent volume claim, right? There are other components. There are components like configuration components, metadata components. So how do you make sure the consistency of a snapshot across all of these components? And that's where Robin, automates a lot of stuff. With a single command, you can actually register any Helm application or an operator deployment to be a Robin application, right? And from there onwards, Robin will take care of managing all of the components of the application. All of the related objects will be wrapped in a single entity, and it makes it really easy for developers to actually then snapshot or back up those applications. And some of the examples here are, application consistent snapshots, right? So how do you recover from user errors? So let's say you delete something by mistake, how do you recover from it? Or if my upgrade fails, how do I go back to a point in time where my system was stable, right? So here, Robin actually makes it really, really simple. You simply have to say Robin snapshot, an application name and the snapshot name, and we will create the snapshot that includes all of the related objects to that application, not just the persistent volume claim. And because of that, the rollback also becomes really, really easy, right? Because once again, you have to just fire a single command, Robin rollback snapshot to application for the application, and then it will actually restore everything, not just the persistent volume, but everything to that stable state and point in time. One thing that I would like to mention are these are redirect on write snapshots. So it takes a few seconds to create a snapshot because we are not copying the data over. And these are also very efficient on the storage side. We are not creating copies every time you create a snapshot. We are basically creating pointers and metadata, right? So it is very efficient on the storage side. Now, going beyond snapshots, right? Let's say you create a snapshot, but that snapshot, since it is redirect on write, it is on the same disk, right? So how do you make sure you can recover from disk or server failures? Or even let's say your Kubernetes cluster goes down for an extended period of time, how do you recover from that, right? So here, the first step is similar. We create a snapshot, but beyond that, now we create a cloud backup, right? So we take the snapshot, and this time this is a full copy, right? So it could be in the same data center, but in a different cluster, or it could be actually in the cloud somewhere like S3 or GCS, right? So that's where, once again, this is a single command. You say Robin backup a given snapshot to a given bucket, and we will take care of backing up all of the components, not just the persistent volume claim. And that's why restoring from the backup is also pretty easy, because you simply say Robin restore, and you give the repository where the backup is stored and what snapshot you want to restore. And this can be done on a different cluster too, right? So as soon as you do that, Robin will take care of actually bringing all of the components and objects related to the application together, and making sure that the application is now restored to a stable point in time when you took the snapshot. Another key use case, especially for developers, is dev test refresh, right? How do I clone databases? How do I share databases, virtualize databases across different teams? So once again, here Robin makes it really simple with a single command. You say Robin clone, give what snapshot of the application you would like to clone, and give a new name. Now you can basically clone applications within a few minutes, right? And once again, these are thin clones, so very storage efficient. They are not creating copies of your data every time you create a clone. We will only create a copy in the event there is a change, right? So somebody in the new clone actually adds some data that won't be reflected in the original application. From that point onwards, only that change will be maintained as a separate copy. So this is very useful for dev test refresh, where you want to clone production databases and test a few things on your development cluster, or you want to run database reports with it without affecting the actual performance of the database, right? So if you're doing analytics, it's better to actually create a clone or create a gold copy and then create different clones and run different analytics reports on those clones. It can also be used to perform upgrade validation, right? So you should always create a clone and test the upgrade on the clone. And if it works on the clone, it's going to work on the production database. And the last key feature we're going to talk about is multi-cloud portability, right? Or multi-cluster portability. So the way Kubernetes is used today, typically most of our customers have multiple Kubernetes clusters, right? And sometimes these clusters are actually created across different environments, right? Some are on-prem, some are in the cloud. Even in the cloud, some of them are in AWS, some of them are in GCP. So that is the backdrop here, right? That is how Kubernetes is used today. So how do you make sure that when you want to move an application from cluster A to cluster B, it goes seamlessly and it is easy, right? It's pretty easy for the stateless applications, because you take, maybe your YAML deployment or a Helm chart and you simply create the same application using the same parameters or values on the target cluster. But stateful can be complicated because now you have data and multiple other things, right? So that's where Robin, once again, makes it really simple. You create a snapshot on your source cluster, then you push that snapshot to a cloud object store using a single simple command. And then in your target cluster, you just, once again, use a simple command that says pull a snapshot or pull a snapshot from this common backup repository, right? So that's where, if you see on the screen, there are different environments as well as different flavors of Kubernetes. So you created a snapshot on upstream Kubernetes on-prem, but you restored the application on EKS or GKE, right, on different clouds. So that is also supported by Robin. We make it really easy to basically collaborate across different teams, different regions, by creating a single common repository for all application backups. Now, this can be used for collaboration, for archival processes, or even for disaster recovery and application portability. So with that, I would like to wrap up my presentation. But before I hand it over to Madhura for demo, I would like to share a few resources with you. So one is get.robin.io. This is our developer portal, and we have a free for life version or edition of Robin Cloudnative storage available. It's called Robin Express, and it is available at get.robin.io. It is free for life. You can simply start using it today. Our documentation is at docs.robin.io, right? So if you want to look at specific functionality and how Robin works, feel free to go to docs.robin.io. You'll find extended documentation. And please feel free to join our Slack channel. This is where you will find expertise on Robin Cloudnative storage as well as on Kubernetes. And if you need any help or if you have any questions, this is the fastest way to get to us, especially if you're using the free edition. And with that, let me hand it over to Madhura for a live demo of how to deploy and manage Postgres on OpenShift.
Great. This is Matt, your host. While we're switching over to Madhura's screen, I just wanted to remind folks that because you're in listen-only mode, if you do have a question, please submit that in the question module. We see a few of those coming in, which we appreciate, and we'll have some time to answer those after we go through this product demo. So I will hand it now off to Madhura.
Hello, everybody. Good morning. Hope you all are doing good and staying safe. I'm Madhura Gavnikar, Principal Engineer at Robin, and I've been here for the last 5 years, and it's been an exciting journey so far. For today's demo, I will demonstrate how we'll deploy a Postgres Helm chart using Robin storage. Then we'll move to creating snapshots of PostgreSDB. We'll back up that snapshot to the cloud and then port it to another cloud. So without much further ado, let me start the demo. So I have created an OpenShift cluster on AWS. Let me show you that. So this is my AWS cluster wherein I have 3 master nodes and 3 worker nodes. I have also deployed Robin on these clusters. And let me show you that too. Let's move to showing storage classes, right? So by default, AWS on OpenShift comes with GP2 storage class, which creates AWS EBS volumes. And then we see here Robin. So this is the storage class which we'll use today so that we can avail the advanced data management capabilities that Robin provides. So before we start, let's create a Helm chart. For the purpose of the demo, today we're going to use Postgres Helm chart. So this is my Postgres Helm chart, and you can see I'm using IBM Postgres chart today. And very important thing to note here is I'm using Robin storage class. So we're using persistent storage class as a Robin. If you don't use this, you won't be able to use data management capabilities. And rest all things here are basically the rest of the settings that are needed to make Helm chart work on OpenShift cluster. So let me show you what's happening, right? Helm list. So this is the Helm chart that was called as movies that I have deployed. Let's see what happens to PVC. So Robin has created this PVC for you that's called as data movies Postgres SQL 0, and it's using the storage class Robin. Let's get pods. Okay, so now our pod is up and running. As we had used Robin storage class, let's go ahead and see if Robin has been able to detect this Helm chart. Voila. So here it is. So Robin has detected, as I have used Robin storage class, it was able to detect the Helm chart, and it has added to its database cluster. So here on, we can use advanced capabilities that Robin provides to like snapshots and backup, and here so on and so forth. So let's enter into the database. So we have logged into the database. Let's create some tables and records so that we can use this. So before that, let's connect to PostgreSDB. Let's create some database. So we'll enter some data into the cluster, and then let's see how it goes further than that. So I've created a database. It's called as testDB. I've entered into the database, and let's create a table. So my table will be called as movies. Now let's insert some data into the table. I've inserted 9 records. These are like movies from the IMDb. I've selected some random 9 movies, and I have added them to our database. Let's make sure. So select start from movies, and we see here that we have 9 records in our database. So at this point, when we have 9 records, let's create a snapshot from that database. So we see Robin app list, and we see that there is an app called as movies, and let's create a snapshot out of that. To create a snapshot, all we have to do is tell Robin create snapshot, name of the app, whatever the snapshot name we have to give. For the convenience, I've given snap 9 movies because we have added 9 records in the database. And let's go ahead. So what this will do is Robin snapshot just does not create the snapshot of your data, but it also creates the snapshot of your configurations and metadata. When I say configurations, I'm talking about config maps and secrets and PVCs. Also, in terms of metadata, when I say it means labels, it takes care of your pods, services, and stateful sets, daemon sets, everything. So this snapshot is a whole package in itself. So let's see, Robin. Snapshot list, and here we have our snapshot. Now, what all can we do with this snapshot? This snapshot can be used to create clones, to restore your application and create backups and so forth and so on. So just to create some excitement, just let's delete one record. So I'm deleting this June 9 movie, which is a horror film from your database. And let's see how many records I have in my database now. So as I deleted one movie, I have 8 records. But keep in mind that when I created the snapshot of the application, we had total 9 records in the database. At this point, this snapshot can be used to restore and go back to the state wherein we had 9 records, or we can continue with the 8 records from here. So just to give you a idea that this snapshot can also be used to create clone, and your clone app will have 9 records as it was there when we had taken the snapshot. So basically, snapshot is like a checkpoint for us here. So further to that, let's create a backup of this snapshot. To create backup, at first we need a repository, like a bucket on an S3 or GCS. So we have to add that repository to Robin first. So I've already added one repository that is called as PGSQL DB, and I have used S3 bucket here. Name of my bucket is Robin PGSQL, and the path is demo1. So here, when you create a repository, we basically need access keys and secret keys as it is in S3 bucket. So that's how you let Robin know to use that repository. Now, what do we do next? Next, we have to attach this repository to the movie. So what we do is Robin app attach repo, movies, and PGSQL DB. So basically, we are telling Robin that use this bucket to store my snapshots or other app-related items. So let's go ahead and create a backup. So what I'm going to do is I'm going to create a backup of the snapshot. So let me give you Robin snapshot list, and we'll create a snapshot. We will create a backup. So Robin backup create, name of the application is movies. This is my backup name and the snapshot ID associated that we want to use. So this will create a backup of our snapshot and then post the segments of the data that are needed onto a cloud on S3 bucket. I have used S3 bucket, but we could very well use here GCS bucket that's provided by GCP. Again, just to reiterate, when I'm saying we are creating a backup, it's not just that we are copying the data, but in here, we are also copying the configuration file, configuration and other aspects that are needed to recreate an app on another platform. So with this backup, we can port apps across multiple cloud environments. This allows you to avoid infrastructure locking and achieve better cost economics. Let's do Robin backup list. Okay, this is my backup ID. So what we're going to do with this backup ID, we are going to use this to create exact same app as we had created on this cluster, on our target cluster. For the purpose of this demo, I'm going to use another cluster as GCP cluster, just to show you that we can move data across clouds without any vendor locking. So this is my GCP cluster. Let me show you what all I have here. So this has, again, 6 nodes. 3 of them are master and 3 of them are worker. I have also installed Robin on this. So you can see all the nodes that are part of a cluster are also detected by Robin and created a highly available environment. So Robin has its own control plane, which will take care of all the, along with data management capabilities, also it will take care that you have your control plane intact. So again, another thing that we need here is a repository. So what I have done is I have added the same S3 bucket that I had used on AWS cluster over here. So here same PGSQL, AWS S3 bucket, and the credentials that are needed to get access of the cluster. Okay, so now if we have to move this backup that gets created on AWS to GCP, we need to export the token. So I say Robin backup export, and this will generate a token for me. Now this is the token that I need to use on my target cluster. Our target cluster here is GCP. So I have to import this token here. So what will happen here is, I think I did not copy the token properly. No. Okay. There you go. So I have, so that's a good way for us to know that as token was invalid, we were not able to go ahead with it. So as I copied the right token, it recognized it, and then now we can go ahead and see what has happened. So let's do Robin backup list, and you can see that the same token, same backup ID has been, it is able to fetch it from the S3 bucket, and the state is imported. So we are ready, and we can go, at this point, we can go ahead and create a new cluster or new app with the same data and configurations as we had on AWS cluster. So let's go and create it. Robin create movies, and I have to give my backup ID here, and let's just wait. So what Robin does here is that it will create an app, generate PVCs, pull the data from the PVCs, and as same data as you had on your source cluster, and then it will create pods and other services and stateful sets or whatsoever we had on the target cluster, sorry, on your source cluster on this target cluster. While this is happening, let's just go back, let's just go and see the PVCs, right? So kubectl, yes, PVC. Okay, so Robin has already created this PVC for you, and then it's pulling possibly the data. And let's see what's happening. Our backup state, it will create pods, and then it will go ahead from there on. So again, so we know that what happens here is also it will create all the configuration files, snapshots, and everything, right? Let's see, get pod. Okay, our pod is up and running. So it will attach that pod and this PVC, and we will be able to go ahead from there. Okay, so it's Robin has already in a finalized state and it's completed. So what does that mean? Let's do Robin app list. Wow, we have your app in a ready state. So Movies Backup is the app that we have created based on the cluster. So we have to be very sure now, right, that whatever we had added data there is present here. So let's do kubectl get pods. Let's exec into this pod. Okay. Let's now connect to the database. It has used the same secret as it had used before, so I was able to log in with the same password as I had used before. And if you guys remember, I had created a database called as testdb. Let's see if I can connect to it. Yes, it says I've created to testdb. And now, the moment of truth. Okay, here we have the 9 records that we had created in our source cluster on AWS are valid here. If you guys remember, this is the AWS cluster where we had created 9 records and taken a snapshot. And then we had deleted another record and we had 8 rows. And here we can see that from that snapshot had 9 records. So we have here a cluster with 9 records. Awesome, isn't it? So just to summarize what we saw, that all we needed was a global repository, a bucket like S3 or GCS, which is accessible to all the cloud infrastructures. We could recreate exact same application as we had on the source cluster, and we were able to port it to our target cluster just by importing application level snapshots or backups. And all we did this was using just one single command, that's Robin app create from backup and giving the backup ID. So Robin automatically takes care of mapping your configs then to your data from source cluster to your destination cluster. So this is pretty much what I had for us, our demo today. Thank you very much. And I will hand over the session to Ankur. Ankur, all yours.
Oh, yeah, thank you. I just want to keep the screen to the resources slide so that everyone, as we go through Q&A, everyone can track, maybe try to sign up onto a Slack channel or, download a free edition from get.robin.io. So with that, Matt, if we have any questions, I and Madhura would be happy to take on those.
Yeah, absolutely. Thanks, Ankur, and thank you for presenting as well as Medora. I have been looking at some of the questions coming in, so there are a few we want to get through here. First one from Juan is, will we find this on existing cloud infrastructure marketplaces? This meaning Robin Cloudnative storage.
Right. So can you repeat the question?
Will we find this on existing cloud infrastructure marketplaces?
Yes, so we are on Red Hat Marketplace. You can find us on Red Hat Marketplace as well as Google Cloud Marketplace. We are working on AWS and Azure, but at the same time, it's since it is a standard operator, it's pretty easy. You can go to get.robin.io and register, and you can see there are different deployment options available, right? So deploying and trying or even using the free edition is pretty easy, right? If you want consolidated billing, which is, if you are a Google customer or a Red Hat customer, if you want, to buy from their marketplace so that the billing is consolidated, Right now, there are two options with Red Hat Marketplace and Google Marketplace, and we are working on a couple of others.
Okay, great. Thank you. We have a bit of a technical question. What if we only want to back up the data or persistent volumes? Does Robin support that?
Yes, absolutely. Right. So all the application awareness and automation that Robin provides is, you can actually configure it to your choice. So by default, it will actually, encompass all the related objects to a application. But if you think that your configuration or your metadata is better handled through version control systems, and you only want to back up persistent volume claims, right? And you use the common repository or S3 buckets for persistent volume claim backups across all clusters. You can easily do that, right? You can actually, create selectors and labels, and you only label your persistent volume claims with the label you want to back up. So it is pretty easy to actually configure. Although Robin by default will have that application awareness, you can actually fine tune it to your liking. You can actually say, I only want to back up the data, and Robin should be able to do that. Robin is able to do that.
Great, thank you. You mentioned the Robin Free Edition, Robin Express. Are there any limitations on the free edition, and two, how do we get access to it?
So in terms of limitations, I mean, it is limited by the number of nodes you can use it on per cluster. So in a given cluster, you can use Robin Express on up to 5 nodes, right? You can't use it more than that, but that is per cluster. So you can still have 5 different clusters with 5 nodes of Robin each on those clusters. In terms of other limitations, we have absolutely no restrictions, right? So Robin Enterprise and Robin Express both have the exact same features. We are not blocking any features. We are not turning any features off in the free edition versus our enterprise edition. You will have, everything that Madhura showed today, as well as everything you can find in the documentation and tutorials is available in both editions. The only limitation is the number of nodes per cluster, which is 5. And the easiest way to get to it is basically registering on get.robin.io. So, on the screen right now, you can see on the leftmost side, you say download from. This is where you actually register and you choose between the Robin Enterprise Edition or the Robin Express Edition for your Cloudnative storage.
All right, so there's a couple more. So what cloud platforms does Robin support? I don't know who wants
So currently we have Robin on AWS OpenShift, GCP OpenShift, and also on Azure. We also have Robin on AKS, EKS, GKE, IKS, and we also support on Google Anthos. We are certified on Google Anthos as well. So along with that, I would like to say that pretty much along with the cloud, we also support RKE and also bare metal installations of pure vanilla Kubernetes, or also about any other OpenShift bare metal clusters too.
Great. Another slightly technical question. Does Robin do any modification to Kubernetes, and is this Robin's version of Kubernetes?
Oh, that's a very nice question. Actually, no, we do not do any modification to Robin K8s. So Robin runs natively on any Kubernetes distribution. We work on stock K8s and use it untainted. We have our own CSI, CRI, CNI, and our own control plane. So pretty much we can work on any without modifying any underneath OS or any K8s modifications. We can work on any vanilla Kubernetes too.
Great, and this is probably a follow-on to that, is what version of Kubernetes does Robin support?
Oh, okay. So currently we support version 1.15 and above. However, it can work on 1.13, but you won't be able to use all the capabilities that we have in the current version. And that's not because of Robin, because also K8s did not have some of the capabilities, like volume resize. it was not there in 1.30. It came on later version. So Robin tries to keep up with all the things, updates that K-Test does. We have support for all those. So I would like to even say that we make it a point to support at least last 3 minor versions.
Okay, great. Great, thank you. That appears to be all the questions that we have that have come in. As a reminder, as Ankur has mentioned, the best way to try out Robin and Robin Express is to go to the get.robin.io website that's on the left side of the screen there. I'd like to thank our speakers, Ankur and Medora, for presenting today, and thank you for taking the time to hear about Robin. Please check back with us for future webinar topics, which you can find on the events page on our website, robin.io. As a reminder, you will receive a link with the recording from today's presentation, so you should see that shortly. And with that, we will conclude our presentation today and hope you have a great rest of your day. Thank you again.
Thank you. Thank you, Matt. Thank you, everyone.
Thank you.